Hi there, welcome back to the channel. Welcome to something completely different. I've been given the privilege of restoring a little amazing guitar amp from the 60s made in East Germany, something which I'd never seen before. And I really love this sort of project, as you probably know if you watch the channel. I love doing things I've never done before. It's a great learning experience. It's more interesting to work on and so on and so forth. Now, not only did I get one of these amps, it's a Vermona MV3. I got two. That is the advantage of living on an island where nobody knows how to fix this stuff, because ultimately some of the most amazing stuff comes to me. And I normally only accept doing the jobs that I find interesting. So this one I couldn't resist. And the idea was to get both of them working for a friend of mine who has his own recording studio, does a lot of professional recording and so on and so forth. And so I get tasked with playing with some of the most amazing toys in the world. For me anyway. If you enjoy this sort of thing, stick around, enjoy the video. These two Vermona MV3 guitar amplifiers or instrument amplifiers look pretty similar. They both came pretty battered. They've seen better days. These little amplifiers were built in the 60s, late 60s, I believe, in East Germany. And they are pretty simple, pretty straightforward. There are two channels, two inputs, 1 and 2. One is a higher gain than the other. You've got tone controls, treble and bass, and then volume for each channel. You've got a mains indicator, a dual lamp, on-off switch and fuse, everything on the front, no frills. And looking at these two guys, someone's been at both. We can see that from the sockets they put in there. In fact, the one on the right has got the sockets floating around. So these things have been pretty battered. And from the front, I wouldn't take much from one to put on the other. But when we look inside, things start getting a little bit more interesting. Well, this one doesn't look so bad. We've got 5 tubes, 2 transformers. This one's the power transformer. This one's the output transformer, and that is a big transformer for a small amp. It is, yeah, it's big. This is a push-pull transformer. It's got 2 EL84s in push-pull configuration, output stage. There are 3 other tubes. This is a 12 AX7, ECC83. This is the phase inverter. And then we've got 2 input tubes. One is a 12 AX7, ECC83, and the other one is an EF86, which if you know anything about amplifiers, it's the pentode, which some people say creates better harmonics than the 12AX7 in the input stage. It's used on the Vox, some of the Vox amps. It does, however, bring with it some problems. They're microphonic, they're very sensitive, etc., etc., etc. But someone has been in here. We can see that. I don't see much change around here, but I can see some wiring that went on, and I think that was to do with the replacement of the sockets. So I'm not sure what the condition of this is. I have no idea. I'm going to remove the tubes because what I will be doing is I will be powering it up under very controlled conditions. And I want to see what the power supply is like. Also, if I take the tubes out, it gives us a chance to have a closer look at the board. This is all done on a PCB. Now, 1967, I think it was. This is quite old. So we've got... these are, I think they're really film caps. I'll have to check. These are not paper caps. I believe they're film caps. 630 volt film caps. And I'm not sure if these were replaced. I don't think so. They look original. Some of these resistors, all the resistors look original. Electrolytic capacitor, which will be changed. This is a dual cap, 2 by 50 microfarads, which will definitely be changed. Rather beefy rectifier diodes. Again, I'm not sure what condition they're in. This resistor seems to have got a bit warm. But that's par for the course. This has been around for quite a while. It does not mean that it's damaged. I'll have to check that. And this is where someone's messed around by replacing these jacks. And it's a pretty shoddy job. This capacitor almost seems like it's broken connection somewhere. All this wiring seems to be original. The speaker socket at the back there has been replaced as well. But overall, this thing doesn't look bad at all. We've got something here that is interesting. This is a trimmer, and if I'm not mistaken, I've had a very brief look at the schematic. This would be to balance the 6.3 volts AC heater windings. If you don't have the 6.3 volts heater winding, heater supply reference to ground or center tapped, you put a resistor, you put a trimmer across it with ground at the back, or the wiper, and then you can adjust the trimmer to get the least amount of hum. It works pretty well. It was done sometimes with 2 fixed resistors, sometimes with a trimmer like this one. So we'll have to see if that's operational. I have not powered this up yet. I have definitely not powered this up yet. I'm going to be powering it up just as it is because I want to see, well, if we have excessive current drain, if we have any problems with the capacitors. I'm sure this cap will be gone by now, but I want to see what the supply looks like or works like. And I'll be checking the output transformer as well to make sure that it is functional before we go any further. Now that is this one. The other one, which is this one, looks like someone's really gone to town. It's a bit of a mess. And the first thing I notice is that the transformer is different. This transformer definitely does not look like that one. Not at all. In fact, someone went crazy with a metal bracket here, which they seem to have added to try and fit this transformer, which is smaller than the other one. And, oh God, look what they've done here. This here seems to be the heater supply, because I see it going to the dial lamp, the dual lamp at the front. And they've just put some tape on here. It's thin wire. Oh God. It's going to the right place on the board, but they really just hashed it together on here. These caps have been replaced. They've put in, okay, the rating's fine, 100 microfarads, 400 volts. That should be okay, but very shoddily done. Very, very shoddily done. Let me take the tubes out again. I'll put these separate from the first one because I don't know what the condition will be. Again, two EL84s, ECC83, another ECC80. This is the EF86 over here. I might have identified the other side wrong. This thing's got a shield on here, and this is the other ECC83, okay? And look at that. That thing looks pretty cocked up. Capacitors replaced here. This socket completely loose. That one completely loose. These things flying around. This wiring's been replaced. Oy vey. The output socket, the speaker socket's also been replaced. These guys seem to be original. Quite a few components have been replaced over here. These capacitors look different. They still look period correct, but they're different to the ones on the other amp. These resistors seem okay. This has definitely been tacked on here. Here's another resistor replaced, another one, another one, another one. Whoa. Well, this one's seen a lot of work, or a lot of damage, I'm not sure. Actually, due to the fact that the mains transformer has been replaced, I think this thing might have suffered a bit of a blow up. Probably a pretty dramatic one, because normally when a power transformer goes, it's because something has seriously gone wrong. You got a fuse on the front there to prevent that happening. Obviously, it doesn't mean that it can't happen, but yeah. This one has seen some hard living. I'm going to be powering it up as well, just like this. And the way I'm going to do that is I'm going to put it through the dim bulb limiter with a lot of restriction on the dim bulbs, and with probably set the variac to half the voltage. You know, we work on 240, 230 here. I'm probably set it to about 120 volts and slowly bring it up. And well, really the only thing I can monitor at that point is the B+. So I'll be checking, it's probably on one side of this resistor over here. So I'll be checking what sort of B+ we get, see if the filter caps, see if the transformer's working, see if the filter capacitors and the rectifiers are working, and hopefully nothing goes bang. There's not much that can go bang over here, but you never know. I mean, the tubes are gone, so what we're left with really is a lot of passive components, but you can never tell. That's why experimentation is so much fun. Okay, variac set to 120 something volts, about half what we have here. Dim bulb, I've put all these guys off, just leave a 40 watt bulb on. It's on limit, and then I can just switch on here. I'm not going to switch on yet because I'm not sure what the power switch is set to. Our meter is connected, and I'm measuring the voltage between ground, which is the chassis, and that leg of that resistor, which is the B+ coming out of the rectifier diodes. So let's sit well back and see what happens. I'm going to switch on at the dim bulb. I'm not sure if the amp, oh, the amp is switched on. So let's see. Oh, Oh boy, oh boy, oh boy, oh boy. I can see a problem already. Let me do that again and show you. See that? That is at the output transformer. That is not good at all. First thing I'm going to do is measure continuity. I know the B plus is over here on that side of that resistor, so I've connected the multimeter to that, and I'm going to measure to pin 7 of each of the EL84 tubes, because I know that the B plus goes into the primary, the center tap of the output transformer, and then one goes through a winding to the one anode and the other one, and then it goes through the other winding to the other anode. So there's one of the EL84s, that's 987, about 319, 320 ohms, that's good. 987, oh dear, bugger all, that is not good. That is not good. Okay, this thing's coming from there to where? That looks like the middle there. Yep, that's it there. So that's the center tap. That's where B plus comes to, and in fact I can see it's down here. So center tap is over there. That thing is coming off there to there. So that is the one output. There's nothing there. And there's the other one. That's the other anode. I presume this one goes to that one. And there's our 320 ohms. Right. Our output transformer's got one of the windings blown. And that is a serious problem, because this output transformer is actually more important than the power transformer. The power transformer you can sort out quite easily. You just find one with a mains, whatever mains you have, primary, and a secondary, I believe it should be about 240 volts. And you can literally replace it. Oh, and you also need a 6.3 volt heater winding. But you can get those. You can get a lot of those. In fact, you can salvage one of those from an old tube radio. The problem is the output transformer. This output transformer is pretty beefy, as I mentioned, and it is really what gives the amplifier its tonal characteristics. You know, what is it going to sound like? How is it going to react? This thing's a push-pull transformer, and usually push-pull transformers are much smaller. Now, the fact that this thing has got so much iron on here tells me that this is incredibly important to give this amp its tonal quality. So we can't just grab any old output transformer and replace it. There is one other possibility. There might be a loose wire in here, so I might be able to take this open, or open this up and see if something is funny over there. But the fact that this thing was shorting down here tells me that this transformer is more sickly than just a broken connection. That is quite a sad outcome. When I said something catastrophic must have happened to blow this guy, I had no idea that it would actually extend to the output transformer as well. What a shame. What a shame. Well, let's stay hopeful and look at the second amplifier. Okay, everything is connected again. There's our ground. There's our B plus that I now know goes to this center tap. I've got the same restriction. I've got one 40-watt light bulb and the dim bulb limiter, and I've got the Variac with about 124 volts. The switch is on. Let's see what happens. I'm going to stand by the switch just in case. I don't see any excessive current draw. 200 volts. Everything seems to be pretty stable. No smoke, no smell. Okay, let me take this up a bit to about 150 volts. That's gone up nicely to 242. I believe it should be about 300 volts DC, but let me take it up to 200 volts mains. This is about 200 or 205. Whoa, it's going a bit high. That's not surprising because we've got no tubes in there, so it's drawing very little current. In fact, I'm looking at the dim bulb limiter. It says 30 milliamps. What is it powering? It's powering 30 milliamps is actually quite a bit. It'll be transformer losses on the original transformer. There may be some discharge resistors here across that capacitor, and the dual lamp which is on, which I'm not sure how much current that draws, but it won't be much. Well, that is good news. That's very good news. So we don't have any smoke yet. I'm going to put in the tubes, I was going to say, and see if we get any smoke. See if we don't get any smoke. I'm going to switch it off. Watch that. It goes down very slowly. So you've got to be incredibly careful when you do this, because you can get zapped. You wait for 10-15 seconds and you think, should be okay, and it's not. So I like to use this discharger. This is a little project that I did, and I touch the B+. It lights up, tells me it's discharging, and I can see it on the meter. It's come down to 1.8 volts, which is fairly safe, and I can actually speed it up a bit more there. So our capacitors are now discharged, and I'm going to put in the tubes from the ones that were on this particular set. 2 EL84s, AX7, 12AX7, and the EF86. Okay, shall we try it again? I'm going to put the volumes down low because I don't have a load on here. I don't have a speaker on here. And you should definitely not run tube amps without a speaker, without a load. But if there's no load, if there's no volume, there's no signal. So I'm going to hit it again. Actually, no, I'm not going to do that. I'm going to take it back down to 120 volts. 120 volts, and let's hit it. Okay. Do I see the tubes glowing? I don't think I see the tubes glowing. In fact, that is strange. I don't think I've got heater voltage at all. Let's have a look. I should be able to measure heater voltage over here. Actually over there. .3. I know what it might be. It might be just the fact that this thing is so low. It's half the voltage and it's not enough for us to see it. So let me put this back on there and put it on DC volts and increase the voltage to 160. Still not much. 200 volts. Oh, I can see the heaters. Yeah. I can see heater glow there. I don't see it there, do I? I can see that one. Yeah. The heaters are on. I can see them. And I've got 214 volts. And I've got my dim bulb glowing. So it's trying to draw more current. I'm going to give it one more dial lamp. One more lamp. $255. Give it another lamp. Something is buzzing over here. Well, it is working. 270. I'm at 200 volts on the mains. I really am just wanting to see if anything goes badly, and I don't see that happening. I think this one is healthier than the other one. So what I'm going to do next is I'm going to put a signal through here and see if we hear anything. Right, I'm feeling more optimistic. Okay, let's see what we've done here. I've got a speaker connected here. It's a guitar amp speaker. I've got a input into input 1. I haven't connected a source. I'll just touch it. Let's hit it. I can see the dual lamp, the dial lamp, the dual lamp is on, and the switch is not working. So it's on all the time. Okay. Do I hear anything? This is the volume for channel 1. Oh, I do. Whoa. You heard what I heard. That did not sound healthy at all, and in fact none of it was responsive to that was not responding to the volume controls. They were all on minimum. I'm not even going any further. That is seriously ill. So now it gets interesting. That was actually quite surprising, because when I removed the input it still went crazy. So it's got nothing to do with the input circuits. So what I'm going to do next, I know I can fix this because the power transformer and the output transformer seem to be working. So what I need to do now is I need to isolate the various sections of this, starting with the power supply. There's obviously something seriously wrong with those capacitors. That sounded like, actually it sounded not like 50 Hertz hum, it sounded more like 100 Hertz hum, I'm not sure, which means that the capacitors aren't doing their job. And I can already remove the 2 input stage tubes, because the first section of our troubleshooting won't go there at all. The first section of troubleshooting is going to be feeding a signal into the phase inverter, the input of the phase inverter, and see if it goes through the power stage to the transformer and out the other side. I'll be showing you the schematic in a second. You'll understand what I'm doing. But the first thing to do is to sort out the power supply. We're back to familiar territory. Follow the rules. Power supply, output stage, preamp stage, etc. Okay, now it starts becoming fun. Right, folks, there's been some progress. You might be able to see it. There are a few little changes over here. And the first thing, as I said, is the power supply. So what I did is I removed the filter capacitor. That main filter cap was just gone. It's one of those dual in one. But the holes on the board are perfect for putting 2 47 microfarad Nishikons on there, 450 volts. Those are perfect. I checked the rectifier diodes. They're fine. They're silicon. They're old, but they're fine. And I checked all these components over here related to the power supply. This resistor is perfectly fine. There are a few things on the actual input before the primary that I had to change. And starting with the switch, I put in a new toggle switch. Perfect. The fuse holder is fine, but there was a bit of a cracked lid on there. So I 3D printed a new bezeled cover on there. Fits perfectly. It's in black. So that is all fine, meaning that the start of the power supply, the primary side of the power supply, was completely rechecked. And then, of course, the only part left on the other side was were the filter caps, obviously having checked the diodes, and checking this humbucking or hum elimination trimmer. But let me show you on the schematic what I'm talking about, and we'll take this one step at a time. As you can see, quite a lot has been painted up, but let me focus on this section, which is the power supply. As you can see, the switch was replaced, the fuse holder was slightly repaired, all good, checked continuity, checked everything else, it's working fine. That is perfectly fine. The dial lamp is coming on. I set the this little trimmer pot to the halfway. It's a 500 ohm pot. In fact, it measures 400 and something. So I put it halfway, leave it there for now. We'll see what it sounds like. Replaced these 2 capacitors. That resistor is perfectly fine. And then that goes up to the center tap of the primary of the output transformer. Continuity was checked to the anodes. That's all fine. And then all these components were checked. Now remember, these are the 2 power tubes. This is the phase inverter. It's 1/2 of an ECC83 or 12AX7. Again, continuity checked. I replaced the cathode bypass capacitor here, 100 microfarad. It was pretty off. It probably would have worked well, but it was replaced just to be sure. So we've got the these two tubes are cathode biased, and there's the bias resistor, 130. In fact, on the board there's 120, and it looks pretty much original. So I think that's a slight change to the original. And what else did I do? I checked all these resistors. Some of them are slightly off, but only marginally. These two capacitors, these are very important here. They do stop DC. These are basically the ones that are feeding each respective, or the grids of each tube. Those can leak and they can blow the tubes, and then the output transformer and so on. These two were perfectly fine, those two over there. They were perfectly fine. However, when I go one step further back to the phase inverter, this one was leaking like crazy. So I replaced that. And this is the first place where I'm going to test the results of all this work. Because what I've done is I've put in a new capacitor there, but I've only soldered this side in here. That leg is in the air, and that is it over there. So that leg is in the air. There's another one back here. I'll speak about that in a second. So if I feed a signal into here, reference to ground or chassis, what am I getting? I'm actually feeding the signal that would come from this preamp tube. This is a phase inverter, this is a preamp stage, an amplification stage. So when this thing amplifies the signal that comes in at that end, it then is picked up here and fed through that, coupled by the capacitor to that point there, which then gets phase inverted. One phase, let's call it a positive phase, goes to that tube. The reverse or the inverse goes to that tube, and that's how you get push-pull. So that capacitor there is not connected to this point over here. It's in the air, and it allows me to feed a signal from a signal generator into that, referenced to ground, of course. And that's the same thing as taking a guitar tone or guitar signal that's being preamplified by that point. Now, I'm not sure what amplitude I'm supposed to use. I'm going to start, say, with 20 or 30 millivolts. And what I want to do is I want to hear it. So I want to feed it in there into that capacitor. It'll go through the phase inverter. It'll go to the two power tubes. It'll drive the output transformer, and that will drive the speaker. And that's the first test. Now let me show you what else I've done. I've replaced the speaker sockets, the jack that was on there, really crummy. I replaced it with one of these. These are very good quality. And I have a problem with this kind of setup here. Let me tell you what I mean. There's our new speaker socket, but it is a jack. It's a 6.3 millimeter jack. Now here's the problem. That socket is identical to the input sockets that I'm going to have over here. So someone could literally, mistakenly, connect to their guitar to the output, or connect the speaker to the input. It won't have much of an effect. It won't do much damage, but it's not going to work. You've got to be careful with that. Now that's why on the original, if I'm not mistaken, these two were jacks, but this one was a DIN connector, an actual speaker output connector. I can understand why they did this. It makes it easier to connect to modern speaker cabs, but it's still something you have to be aware of. However, again, these two are going to be identical to that one. I haven't touched those inputs yet because I am only going to be dealing with the output stage. Another thing you might notice is that this faceplate looks a hell of a lot better. What I did was I touched up with a very fine brush, not this one, much smaller than this, with black paint. I touched up any scratches that I could see on here, and this will come off. And then I sprayed it with a matte lacquer because the black was fine. This is obviously after cleaning it, and it is much, much better than it was before. So this faceplate is looking pretty good. I also took the screws and I made sure that I had identical screws. Remember, I've got 6 more screws on the other, on the brother, the one that's pretty damaged. So I took these identical screws, cleaned them up, de-rusted them, and put them on here. This thing's looking really good. And I'm trying to find paint for this because I do want to spray it, but that's the second stage. So our amp is ready to go, and I want to test it, see if we've got anywhere with this thing. All right, folks, time for testing. I'm going to connect the signal generator to ground over here, and I'm going to connect it to that capacitor, which, as I said, is the one that's going into the phase inverter triode. And I'm going to switch it on. I'm still on just over 200 volts mains supply. I don't want to give it full mains just yet because I want to see what the final voltage is on this thing once I've got the other tubes and all that sort of stuff done. I'm putting the signal generator to 20 millivolts RMS and switching it on. I can see the dual lamp on, the dial lamp. Give it a bit of time and see if we can hear anything. I'm going to give this a little bit more amplitude. It's up to, oh, I can hear it, 100 millivolts RMS. Yes, yes. I'm going to drop that a bit. It's fairly high. 30 millivolts RMS. I'm listening to the speaker, which is on the floor here. And it sounds good, except for a bit of hum. Now that doesn't really surprise me because I haven't adjusted the hum cancellation, if that works at all. Also, let me put that off. I know that's working. Can you hear the hum? I want to know if that is 50 hertz or 100 hertz hum. It sounds like 100 hertz hum to me. Okay, I've confirmed that that is 100 hertz hum, which means that it is hum from the rectified DC, not from the mains. So that humbucking thing there will do absolutely nothing to it. And I'm not going to take that too seriously right now because I am feeding it into this cap. I don't have the right impedance to ground there. There's all sorts of reasons why this hum may be more pronounced. And I will judge it when I get closer to the finished result. Remember I said that I had two caps in the air. This one here, the one that's feeding the phase inverter, and one at the back there, that one back there, which is the one that feeds the preamp stage in this dual triode. So what I'm going to do next is I'm going to solder this wire down there, and then I'm going to feed the signal to there, and obviously I'm going to reduce the amplitude of the signal because that's a preamp stage there. It'll probably require less amplitude to give me the same audible tone, which you can hear quite well. All right, let me try that. Whoa, that is loud. This thing is being fed 2 millivolts RMS, and the hum is very loud. If I turn off the signal, that's what you get. Now bear in mind, as I said, I'm not too worried about this just yet because I wanted to check that the audio stage was working. Let me switch that off. It really is annoying. I wanted to check that the entire audio stage is working, and it seems that it is. I mean, the whole thing is audio stage, but what I mean is the amplification stage. And what we have here is precisely that. We have the audio coming in to the preamp stage here. It's an amplification stage, one triode of this 12AX7. It then feeds or drives the other triode, which is the phase inverter, which then provides the two phases to the push-pull tubes, the EL84s, which then drives the transformer primaries in push-pull, and you get the signal coming out of the speaker. Now, we do have feedback from the speaker. This wire here comes from the speaker connector over there. And I have changed the socket for the speaker, and I made sure that I got the right one. You don't want to feed back ground. That would do nothing. I'm definitely feeding back the output itself, and that goes through and it comes to this preamp tube as feedback, which should reduce distortion. But this stage is just far too early to worry about actual distortion and hum because we've still got a lot to do. So my next step would be to go to the input stages where the tone shaping happens, because you've got your tone controls, your volume control. The one stage here uses the 12AX7, and that uses both triodes, one driving the input signal itself, and then it goes through the tone stack over there, and then the other one boosts that signal after the tone stack. And the other one, this EF86 one, just has the one pentode, the one tube. It's a single tube inside that envelope. So that's going to be fun, and that's where a lot of the tone shaping happens, where the very specific characteristics, tonal characteristics of the two tubes really come in, and hopefully where some of the noise that we're getting can be, well, sorted out by getting everything connected together properly. But that's where I'm going to stop this video for now, because I've got quite a lot to carry on with and I want to do it properly. I don't want to rush it. So I'd rather restore the inputs of each channel in the next and final video in this little mini series. And for now, I do hope you've enjoyed that. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, please do so on Patreon, PayPal. Links are in the description below. So once again, thanks for watching. Bye for now. And most of all, stay sane.